to our subject physics GRE. So 95 in the cycle shown above KL. Also, basically you can read the question. This KL means the isotherm, and the KN means the, so these two are adiabatic. These two are isotherms. So this is Carnot cycle. So what you need to remember is that the Carnot cycle has the hot reservoir T2 and the heat Q2, and then the T1 Q1, and the work is just Q2 minus Q1, and the total system entropy is 0. So this is the property of Carnot cycle. You need to remember. Okay, so the first one said that A is correct. A is correct. Basically, this means that Carnot cycle is the most efficiency process. B said that the entropy of hot reservoir decrease because the heat comes from Q2. We extract heat Q2 from here and put some Q1 in the cold reservoir. So Q2 entropy decrease because heat flow out. C, the entropy of system decrease. This is not correct because I already said that system entropy is fixed. And the D is just the network, right? This is why I write, right? Because energy mass conservation. And the E say that the efficiency cycle is independent of working substance. Yeah, so basically this is the property of a Carnot cycle. Okay, so 96, he said that you have an infinite deep square well potential. Okay, so you need to remember this type of results. Basically, you will have this one, somehow something like this one. So some even function, some odd function, and some even function, some odd function. So this is your original wave function. And the small perturbation v prime. Okay, so basically v prime is what? V prime is some some even function, right? Some even function. So he said that the phi 0, phi 1 have energy level of particle in the infinite deep. So this is phi 0, phi 1, phi 2. So phi 0, phi 2 are even. Phi 1 and phi 3 are odd. Okay. And ask about the eigenstates. The phi 0 prime in the perturbation v plus v prime. Okay, so ground state. So what we know is that phi 0, phi 1, and phi 2 are complete bases. So that means we can write any function satisfy the same boundary condition to like an phi n. So this is not related to physics. This is just say that phi is complete basis. Okay. So it seems like that. So the first one is definitely not correct, and the BCD looks possible, right? But remember that the ground state is even function. So the even function can be used as an expansion to any even function. So that means we know that this an will be 0 if n is odd, right? Because you're basically, especially when your perturbation is also an even function. So we know that if the potential in one dimension is even or odd, then we can choose a wave function to be even or odd. So our original ground state is even. So after an even potential perturbation, it should still be even. So B said that this A0 with all the odd. So B should be the answer. That's it. Okay, I think it's enough for today, and I will see you guys in the next video.